You are in here for CloudBots, harvesting crypto coins like a botnet farmer. And it's my pleasure to turn it over to the very well-dressed Rob Ragan and Oscar Salazar.
Welcome, and thank you everyone for joining us this morning. I'm Rob Ragan, and this is my best friend, Oscar Salazar. We are penetration testers for Bishop Fox, and we want to tell you today about some of our latest research and a really exciting project we've been working on for the last year, where we were able to build a botnet with freely available cloud services. But a few main topics that we really want to make sure that everyone walks away with after this is really exploring, like, is it possible? And is it possible to build a cloud bot or a botnet with cloud-based services? The answer is undoubtedly yes. But it's one thing to know it's possible, and it's another thing to see how it's done. And we want to show everyone here how it's done. We also want to explore the question, will we see the rise of more botnets of this type? We also think the answer is undoubtedly yes. We're certainly not the only ones doing this. I think we are some of the few that are actually publicly talking about it and explaining the steps that we took with our particular process, and we want to share that so that everyone in here that is a security researcher or penetration tester can learn from these techniques and help build upon them and help organizations understand this threat better and better. And we really asked the question while we were doing this research, is insufficient anti-automation of an overlooked risk? Or is it on scale with the OWASP top 10 for application security risks? Will we see, not just in cloud-based services, an increase in automated attacks over the next few years, or will we see all online services be more and more affected by automated attacks, and how can organizations prepare for that? So that's something else that we hope everyone takes away from this research.
So what are we talking about when we talk about cloud-based services? Cloud-based services provide a number of different features. Some are processing power, some provide you a place to host code, some provide you with storage, some provide you with IDEs or development environments. But essentially these are services that help developers and engineers more easily create applications and get going on applications.
Right. These are platforms as a service, infrastructure as a service. Maybe some folks in here that are developers use these. It's really designed to make it as easy as possible to stand up a web server and stand up an application and then manage it using a nice interface. It's cutting out all of the legwork and all the time doing that manually, because these services have built a nice user interface around getting a new Linux virtual machine, giving you SSH access, and really letting you build an application as quickly and easily as possible. And this is a commodity that's in high demand. We're seeing more and more services start up that offer this. More startups, more large companies getting into this market, because anything that really makes the life easier for a developer can help IT make an organization more money. And we realized if it's making the life of a developer easier to stand up an application, wouldn't it also make a malicious attacker make their lives easier, make it easier for them to exploit these resources? Why wouldn't they take advantage of it? And that's exactly what we explored as we investigated the possibility of building a botnet using these services.
So there's a lot of services that provide free resources online. So here's actually a list that contains 150 services, cloud-based services that cover all kinds of languages, all kinds of platforms, all kinds of processes and storage.
Yeah, the link at the bottom of this slide will actually take you to this shared Google spreadsheet developed by Cloud Core, and this was one of the lists that we used as the basis for our research. We went through these and we analyzed which technologies they use, which provide SSH access to a Linux virtual machine, which of these are really, and then we also analyzed what types of anti-automation they had in place. And we'll talk a little bit more about that. But we also were able to really leverage a lot of them that aren't necessarily in that list, that are also integrated development environments in the browser. Yeah, those integrated development environments, one of the key takeaways I think to understand there is we actually developed this entire proof of concept without storing any code or using any tools on our laptops. All that's really needed to do this is something like a low-end laptop that has internet access and a browser. A lot of these services that are available now, their whole mentality is you can even do pair programming and shared programming in an IDE that's in the browser. And at that point, nothing actually lives on a hard drive. Everything lives in cloud storage. There's no trace of any attack tools or scripts on any attacker's hard drive anywhere.
All right, so basically the process that we went to get a botnet or to generate a botnet was automating scripts, right? So the idea is to automate the process from start to finish of signing up for an account, setting up that account, and then like managing those accounts. So when we were looking at signing up for new free tier services, some of the hurdles that we found, or the anti-automation that was in place, had to do with email address confirmation, CAPTCHAs, SMS, and credit card verifications. And so we found that a large portion, around 66% of the ones that we looked at, only used email confirmation as their sole means of anti-automation.
Yeah, and there are certainly entire areas of research that cover how to bypass CAPTCHAs, how to subvert SMS and phone verification mechanisms, how to subvert credit card verification mechanisms, and especially if an attacker is willing to cross the line into doing illegal activities, using stolen credit card numbers is certainly an easy way to do that. But we decided for the focus of this research, even though we're collecting resources and sharing resources on how to bypass other means of anti-automation, we focused on that email confirmation step because 2/3 of the resources we looked at only used email authentication and confirmation as their means of identifying a user. And we really realized that there still is this notion with a lot of online services that one email address equals one person. And that's a very antiquated concept. That's like maybe 30 years ago, one person only had one email address, but I don't know anyone. None of my friends. I know Oscar has like 16 different email addresses. Every time he wants me to send him something, I have to pick a different one. And basically, no one has one email address anymore. And this concept of using that to tether an account to a service provider needs to change. Especially if the service is protecting something valuable or offering up something valuable for free, we're going to demonstrate how we abused the email confirmation process to really access those services and exploit them with unlimited unique email address accounts.
All right, so this research actually all kind of started from a pen test that we were working on where there was an online sweepstakes as part of the penetration test. And we decided that we wanted to enter in hundreds of thousands of applications to the sweepstakes. And so in order to do that, we needed to have a unique email address and the ability to make the request required to sign up for the sweepstakes. So in order to do that, we actually started using Google App Engine. And Google App Engine actually has something called an inbound mail handler, which allows you to receive an email and internally it forwards it to your application as a post request with just all the contents of the email. So what it allows is for a wildcard local part of your email address, so your username portion, and then they have a fixed domain for you. From that, we were able to extract information from the email, from the subject, extract the activation links, and actually make the request of the activation links directly from within Google App Engine to automate the whole process. So just quickly for a recap, the anatomy of an email address, you have a local part, which is usually your username, the @ sign, and then a domain.top-level domain. And that's typically what you see, and that we'll be talking about those kind of as we go through the presentation. Yeah.
So that Spark, that original penetration test where the organization we were targeting offered up this sweepstakes that had a really valuable grand prize, we wanted to ensure that we won the contest. This was something they were concerned about. Could this be abused? And the answer is, of course. Always, if there's anything offered of value online, someone is going to come after it. Someone is going to try to abuse it. There's probably some folks in here in this room that have maybe automated an online poll or automated a sweepstakes to maybe increase their chances of winning or whatever they're voting for to win the online poll. And we realized if we could harness the power of Google App Engine, harness the power of this inbound mail processor, we could certainly control more entries in the sweepstakes.
Yeah, so the one issue that we ran into while using the App Engine inbound mail handler is that the domain portion was always the same, right? So we could generate different application names, which is the CloudBot mail portion, but at the end of the day, it would be your application name.appspotmail.com and then some portion at the beginning. And so that's easy to identify.
Right.
It's a very identifiable pattern.
Right. And if you read a lot of research on organizations like Twitter or Facebook and they see a lot of attackers trying to generate fraudulent accounts because there's value in having more Twitter followers or value in having more Facebook followers or likes or other click fraud attacks that can occur on those types of services. They look for these types of patterns. A very common defense technique is there any pattern in the local part of the email address or is there any pattern in the domains? Can we do some post-processing to filter those out as fraud? Another penetration test we did for an online poll, they actually expected a certain amount of abuse. They would allow each email address to cast 50 votes and then they would just weed out every vote from that email address after 50. And so they would basically do an analysis of their database afterwards and say, let's throw out all the extra votes from this account. The attacker may think that they got extra votes in on the online poll, but due to that fraud detection, which is actually a very good defensive technique, that didn't work.
Yeah, so if you received 100,000 sweepstakes entries, all that said at CloudBot.mail.appspotmail.com, you'd be suspicious, right?
That looks super fishy. And so a lot of attackers might stop here. They might be like, well, I used this service, I casted 100,000 votes from all from the same domain. Maybe those got through, maybe they didn't. But we weren't satisfied with just this. We're like, we need to take it a step further. We need to figure out a way to generate unique domains. And our initial thought on this actually was that we were going to leverage some free cloud services to generate cryptocurrency and then buy $3 domains on Namecheap. That was actually our original plan. But we realized that would take a lot of time and the economies of scale we would hit a limit. We would hit a wall and how quickly we could grow this system. So we ended up going a different route. Because what we really wanted was email addresses that were unique, that look like this.
Yeah, and so here's a list of 100 email addresses that have very random data and they look realistic, but don't have a very identifiable pattern. And the idea is to be
not get blocked, not get caught.
Yeah, not get caught. Be like generic enough, be random enough, and be human enough to pass the test.
And so how do we generate this list? Let's walk you through the steps. So the first part that we wanted to have no discernible pattern in was the local part. And that's where it's maybe kittenlover123@hotmail.com. The kittenlover123 is the local part. And so in order to generate that section of the email address, we actually scraped real email addresses from online dumps. There's no shortage of online dumps. In the news every week we're reading about another one. There's like Russian attackers stealing 1.2 billion identities just this week and email addresses and credentials. Those will eventually leak to the internet, or we'll have an unlimited basically list of real email addresses to pull from and use that to generate the local part in our system.
Yeah, so those are email addresses that were generated by millions of people. We scraped just the local portion of the email address out, and then we used the next portion, which was gaining the ability to get a custom domain.
This was really exciting. When we got to this step, we were like, wow, we don't need to go to Namecheap anymore. We don't need to generate $3 at a time in cryptocurrency mining to buy more domains. We actually found this service first and then many more like it. This is freedns.afraid.org, which is actually a pool of donated domains. And anyone can go to this site, create a free account, and then they have access to a giant, there's a pool of 100,000 domains that about 30,000 of them last time we checked are freely available for anyone to register a subdomain on. And in particular, you can register MX records, the DNS entry for managing email. And so that's exactly what we did. We actually, so this step of the process, we took one of the free domains from this service or one from the many dozen services like this. We registered a new subdomain on it and then pointed our MX record to our back-end inbound mail processing system.
Yeah, and so one of the problems with Google App Engine when we were originally looking at that as a solution was that Google App Engine does not allow custom domains for their email handler. You have to use their appspotmail.com.
No redirect
domain.
to your own subdomain.
Yeah, so we had to find a solution to get around that. So now we had the ability to register domains and we had local parts in spades, but we didn't have the ability to process the mail at that point. And so these are some services that essentially allow you to receive inbound mail. It converts the email into a JSON format or an HTML post format, and then posts that data to a specific URL that you provide. And so this was kind of tying it back into Google App Engine or whatever service you wanted to have that allowed you to create a post request or receive a post request.
And we're actually maintaining, as part of our project page, if you want to go to the next slide, we actually have a spreadsheet of services like this, because this is an ongoing, we'll continue to keep this up to date as we come across more, and as we use these in our penetration testing efforts, we'll keep this list up to date, and you can go to the link at the bottom of this slide, and we'll keep stats on what the free trial limitations are, and how this can be integrated into, if you wanted to set up your own platform for unlimited email processing.
Yeah, so now we have an email that's in a post request that we're sending to a URL. That URL can be hosted anywhere. There's that huge list of cloud services. You can write this in any language. So essentially what happens now is we receive that email in that JSON format. We extract any activation links. We submit those activation links and automatically register for the account. And so this whole process is essentially you sign up for an account with an email address for a domain that you own, and after that process is completed, your account is automatically activated in the background without any further...
No human interaction. This is, yeah, that step was also kind of quintessential to getting as many accounts as quickly as possible, was automatically grepping through the confirmation email or reply to this to make sure that you are identified as the owner of this email address. We can just scrape those out and automatically submit that request.
And so what we end up with is essentially this list of domain names that we have access to with random local parts. So very, very hard to identify a pattern in these 100 emails that we generated. All right, so just to kind of get a better understanding of how this works, we'll do a little demo of signing up to a service and some of the problems that we would run into if we were using another service or didn't have this exact setup. So I don't know how many of you are familiar with Mailinator, but Mailinator is essentially kind of what we built, the ability to register a random local part at mailinator.com and then go check your email afterwards.
Yeah, but a lot of sites are onto that game, so a lot of sites won't even let you register with a Mailinator account, and this, for example, this is one of them. They'll actually say this domain is not allowed. This is on a blacklist, and we know that that's not a legitimate email address. We want only legitimate users, even for our free trials where we're giving away 10 gigabytes of free space. And so in order to subvert that, this is why we built our own inbound mail processing platform.
Yeah, and so some of the, kind of the same issue that we would have run into if we used that appspotmail.com. Appspotmail could have been flagged as a domain that is not trusted. So that's what we were trying to avoid. So essentially, at this point, we now try to register a domain or an account with a domain that we don't own. And the idea behind this is if you try to do that, you never receive the activation link and you can never use your account.
Yeah, they're still using that authenticate the user by their email address mentality, and that's the only form of anti-automation other than blacklisting some of the services like Mailinator that give temporary unlimited email addresses.
Yeah. And so what we do here instead now is use one of the domains that we set up for the exact same process. You go to the sign up page, you type in your username and your password, you type in an account, anything at your customdomain.com. And once you submit that request form, the backend mail processing forwards it to Google App Engine, and Google App Engine actually clicks on the activation for you. And so as we refresh, we'll see that the account automatically gets activated.
Yeah, we didn't have to go to Gmail or any other inbox and click that confirmation. We're just able to log in now.
And so in the back end, this is kind of the logs that we receive in Google App Engine saying that the account has been activated. We scraped this activation link out and we made that request. And so that's kind of one step of the process, right? So once we're able to do that portion, we're able to automate the rest of the sign-up process more easily. So on the top over here, we see basically the process that we go to automate the rest of the functionality. So once we have mail processing handled, we say, all right, first we're going to generate a username and an email address with a unique email. We're going to submit that registration form. In the back end, like we saw in the video, our back end mail processing will activate the account. Once the account is activated, we can continue our script that we were writing to finish the process of targeting the sign up, logging into the application, and setting up whatever we need to set up for that specific instance to add it to the botnet as one of the instances. Once we're done with all that, we add information to a MongoDB database.
Yeah, this is actually part of how we manage all of the accounts that we've registered. We're actually also using cloud services that provide free MongoDB in a free trial account to keep track of every username that we've registered, all the statistics on if it's a cloud service, what CPU level we have, how much processing power and memory, what port we connect to whenever we SSH to it. If it's a cloud storage service, we can keep track of the disk space that we have, and all the stipulations of the free trial. So we can this is basically what an attacker would use to build a dashboard of their botnet. This is all the information and stats that you would need to know which accounts are under your control.
Yeah, and some of them expire after a certain number of days, so you could add information about when they expire, when they're no longer valid, when you can remove them from the database.
Yeah, and the idea being that there are tons of free MongoDB services and more coming online all the time. We can actually use more than one of those to distribute this type of CloudBot that doesn't just rely on one backend service. In case one were to become unavailable, we have redundancy. So now we actually have the step of registering all these accounts, and we actually have a botnet. What can we do with it? This is where we get into some of the fun parts. We can do things like, and we really focused on what would we want for our penetration testing activities, what would make us more efficient and be able to save time during our penetration tests, which coincidentally also align with things that a lot of computer criminals might want to do. But being able to simulate these attacks and actually, as penetration testers, have a botnet within our control was our goal. So doing distributed network scanning. If we have really large IP address ranges to scan, distributing that job with a distributed nmap across all of those unique IP addresses coming from perhaps all over the world helps protect against getting caught or flagged by an IPS or IDS. Also just saves time in distributing the workload. We explored the possibility of distributed password cracking, but we really focused on only using free tier. If we were using stolen credit cards and buying GPUs, that might have been a bit more effective. But since we were only focusing on free tiers, it really wasn't effective to try to do distributed password cracking with those with the weaker CPUs. Doing distributed denial of service. We actually have clients coming to us and asking us, maybe they're in the financial industry or an industry that's actively being targeted by distributed denial of service attacks, and to be able to arrange for a specific time window where they want to test a DDoS against a particular functionality in their app, and they want to do it in a controlled environment and in a controlled time frame. We wanted to be able to have that ability and actually be able to come from many unique IP addresses from around the world. Click fraud was something that we can explore as if we want to test to see if some of our targets do ad tracking, and we see if we can abuse that system using this cloud bot. And cryptocurrency mining, certainly very interesting. This is where we actually are seeing a lot of activity, and as well as data storage. Getting lots of free storage is also very valuable.
And so for getting large amounts of free storage, there's a lot of referral programs that actually assume that you have a specific set of one email address to one friend correlation. And so if you're able to generate an unlimited number of email addresses /friends.
You're a very popular guy, Oscar. You've unlimited friends.
Yeah. Then you're able to sometimes kind of cheat the system and get a lot more stores than you normally get.
Yeah.
So here's an instance of Dropbox.
Yeah, some services have actually capped the number of friends that you can recommend, and they've capped the amount of space you can get, but others haven't done that. So we actually came across a service where we were recommending friends, and we got a terabyte of space for free on this service, which was actually more than you could pay for in their paid tier. But due to having unlimited friends, We could have gone further. We just stopped at a terabyte. We're
we figured that's probably enough.
Yeah, that's good for now.
But again, all the friends had unique email addresses on different domains, very hard to identify and very hard to track that kind of thing. So putting controls in place to protect your company against that kind of attack makes a lot of sense.
Yeah. And so now we had all these systems, and we wanted to come up with a way for command and control. We actually used a Python framework called Fabric that's designed for system administrators to be able to distribute commands across their data center or their internal network really quickly and easily. If they have SSH access to a Linux box, they can then write a small script and tap into the powers of this framework to distribute that command asynchronously. And so there's what we actually see a couple of commands there, maybe like fab check hosts, do it across 20 threads in parallel, give me stats back on all of the hosts that I have SSH access to. Or you can customize it with commands. And so that's exactly what we did. We actually, here's some output of kicking off a job to curl icanhasip.com and just see the unique IP addresses. And actually all of those IP addresses are Amazon EC2 boxes that we were getting back when we were running this command across a subset of a few different free cloud providers. And we're able to then rapidly command and control that from any machine that has the private SSH key. And so there doesn't necessarily have to be a central point of command and control like in a lot of botnets we see that are spread through malware. There doesn't have to be an IRC channel that all of the bots or zombie computers connect back into. We were managing all of this with SSH private keys, and we could kind of, wherever we wanted to hop through to perform that SSH tunnel was where we could distribute commands from.
All right, so making money. If you guys know anything about cryptocurrencies, essentially it's the ability to generate money using processing power, when it all kind of boils down to that.
A proof of work, typically hash cracking or some form of effort that was quantified into this proof of work for this user or this wallet.
Yeah, and so since we are using only free tiers, we're essentially getting money out of nothing, right? Getting money from nothing. So what we did is we created a command that essentially connected to each bot, then downloaded the Bitcoin mining or the Litecoin mining software.
Which we use because that works better with CPUs. Bitcoins typically work better with GPUs, which we didn't have access to in this free tier. And as Oscar said, we're really generating this from nothing because we're not getting an electric bill at the end of the day. Whereas if we were doing this on a computer in our house, that really tends to, first of all, make it really hot in your bedroom, but also really increases your electric bill. And someone else is getting the bill at this point. This is why this is very attractive to attackers.
Yeah.
And so we didn't want to get caught, and we made this complex command to kind of hide our activities.
Yeah, so it goes and pulls down the mining pool script. It unzips it, renames the mining file to bash, and then creates a screen, starts the mining process, and then actually deletes the file off the file system. And so if you were to shut down the instance, there would be no files on the file system left to track down to see what was going on. And so one night, 5 in the morning.
Yeah, it's like a Saturday night, the weekend that we were working on this proof of concept, we kicked off that command across all of our bots.
We're like, okay, go, let's see what happens. And so we started
had a high five moment too. We were like, yes,
all right,
success,
good job.
It worked.
Yeah. And so we start looking through the logs and start doing some monitoring. We start noticing that a lot of the services that we were targeting looked like they were sharing resources with other users. So we're like, uh-oh, we don't want to cause like financial loss for anybody or cause a denial of service attack for anybody. Let's shut it down. And we were like, crap, we didn't code the shutdown functionality. We only coded the kickoff functionality. So it's 5 in the morning. We're exhausted. We're frantically trying to figure out how we're going to shut this thing out before it gets away from us.
Yeah, I think we eventually came up with we could just go back and kill all those screen sessions that we started to rapidly shut it down. But yeah, we didn't actually want to be malicious with this. So a lot of people have been asking us like, how much money did you make? And the answer is, we won't tell you. But now the answer is we didn't actually want to be malicious, and so we just wanted to make this as a proof of concept and show how it's done and what the steps look like. And so at our peak, we had a kilohash rate that was generating about 25 cents per day based on the current value of Litecoins
per account.
And multiply that, and at our peak, we had 1,000 our goal is to reach 1,000 nodes or 1,000 bots in our CloudBot. And so you multiply 25 cents by 1,000 and you get about $250 a day. And that's just where we stopped. That could scale up even more to tens of thousands of bots. And we've actually heard of some cases of people making a lot of money in a really short period of time doing this.
Yeah, and so we basically kicked it all off and then left a couple running in the background just to make sure that we weren't going to get detected. And we left it for a couple weeks, and no one ever found out that we were doing it. So
yeah, the couple that we left running for a couple weeks, we eventually shut them down. I think we just kind of let those free trials expire. It wasn't really a matter of did we get caught or did we get shut down. It was more of like we pulled the plug on it because we realized that those shared environments may actually be hurting someone's experience. And we didn't actually want to generate a high electric bill for any of these cloud services.
Right, so cloud breakout. So one of the protection mechanisms that we saw, or one of the anti-automation systems that we saw for trial accounts was the ability to only create inbound connections to a device or one of the
you could SSH services in, but you couldn't get internet out. That was their free trial. You got 180 hours on actually some really nice boxes.
Yeah.
They had GPUs. Some of them were Windows VMs that had graphics, and they were really high value targets.
Yeah, and so we were like, okay, well, this is going to take a little bit of extra work, but the payoff is potentially greater. So we spent a little bit of time essentially creating a way to use the SSH tunnel that we had in to SSH all the traffic or tunnel all the traffic out through the SSH tunnel in order to essentially do the botnet mining as well. So just keep in mind that even if you try to put additional steps in place to protect yourself, if it's a high value target, people will spend the time to automate the process and take advantage of it.
Since we could SSH in, we could SSH back out through a gateway server and reroute our internet traffic through that SSH tunnel and still connect to an external mining pool that basically bypassing the restriction of no internet. And we've heard stories of other cloud providers where they've had this type of attack happen. They've had the cryptocurrency miners come in and start taking over and start pegging the CPUs and running the electric bill up. And that was their defense mechanism. It was like, okay, well, let's try to find the binary that they're using and get rid of that. Okay, the attacker just did it a different way. Now let's try to black hole all of their outbound connections to the mining pools. There's actually, you can go on Wikipedia or some of the Litecoin and Bitcoin sites and find a list of all the popular mining pools and try to basically blacklist those outbound connections. That won't necessarily work either. The way that we bypassed that was essentially through this SSH tunnel out to another gateway server and then to the mining pool. And so that was all part of avoiding detection and not getting caught. And so this goes back to the whole concept of a cloud bot and how this differs from a traditional botnet that is based on malware. We had this concept of if someone tried to detect this and start shutting these down, what was our disaster recovery plan as CloudBot herders? And so we actually coined the phrase armadillo up, is where we would just take all of the backups of all of our code and all of our scripts and just roll it over to the next service that did the same thing or had the same functionality. Like we said, we started out using one MongoDB service, but we had backups of all of the registration accounts and all the JSON data in that MongoDB backed up in another MongoDB database that we weren't actively utilizing. Or we took all of our SSH keys and all of our scripts to manage and use Fabric to kick off commands, and we just could roll that package up and move it on to another service. And so this kind of lives in this hybrid state of working across multiple services, multiple platforms, multiple infrastructures, and
it's very easy to migrate the code to any other service or any other provider.
Which is a lot different than the typical botnet that is on the laptop that a new AV signature maybe wipes out a bunch of the nodes and the botnet herder has to go and develop a new iteration of their malware and keep spreading that. So it works a bit differently, and I actually see some appeal because we did like the majority of this proof of concept in one weekend. So someone that is a skilled coder could actively do this relatively easily. And that was something we wanted to raise awareness of because we do think that we will see more of this type of botnet unless these services take more precautions.
So while we were doing our research, we actually started seeing that we weren't the only ones doing this kind of activity. So
we started seeing a lot of this.
Yeah. So a lot of trials being temporarily disabled on some services, requiring credit card or additional forms of verification, and not just email.
Right. And if you're an attacker that's actively doing penetration tests or doing activities for organizations that provide an online service, we hope, or maybe you're responsible for defending an online service, and it doesn't necessarily just have to be a free cloud hosting service. Anything that's doing credit card processing or payment processing or giving away any free trial, maybe it's free storage, maybe it's something completely unrelated to anything we mentioned here, but it's something of value. We want to raise awareness of this so that you don't find yourself in this situation or your clients don't find yourself in this situation. This is reactive.
And this actually hurts your business, right? If you have to stop your sign-up process in order to revamp it and add new protections, you're basically cutting off revenue at that point until you fix the issue.
Yeah, we actually have more and more clients coming to us with this problem, and they're having to shut down their registration or shut down their credit card processing until they put more defensive controls in place and more fraud detection. And that's what you want to avoid. And because we even saw some of them. Here's a free VPS provider that literally said right on their registration page that they had to shut down due to botnet cryptocurrency mining. And
this was not us.
No, that was not from us. We were going to try to attack that one for our proof of concept, but someone beat us to it. This certainly is, without a doubt, a rising trend. We actually, in June, some researchers at Dell SecureWorks in Atlanta, they found this threat that an attacker actually was exploiting a popular NAS, and they were getting a code execution in it, discovering more of these that were exposed online, and then using them for cryptocurrency mining. And they actually generated about $600,000 worth of Dogecoins in 2 months.
And that's running a script very similar to the one that we showed the proof of concept of there, where you essentially just deploy to each one of these services or each one of these NAS boxes, and it just sits there and mines for you.
And so they went through and started trying to identify this attacker to prosecute them, because that is actually very malicious activity, using these network storage devices that don't belong to them. But this is just one example. We've also seen just a couple weeks ago or last week, some examples in the news of cloud services being abused for distributed denial of service attacks. So we, without a doubt, see this being more and more of a trend, and want to talk about how now to protect an online service from these types of attacks. And so we originally said, when we started this discussion, that we focused on sites that were only using email confirmation. So we can certainly see that that is inadequate. It's an antiquated mentality that one user equals one email address. And I know that a lot of startups and a lot of organizations want to get as many users as quickly as possible, and they don't want to cause any annoyances or any hindrance to that. We've heard developers grumble and say, like, we wanted to add a CAPTCHA to the registration form, but the business wouldn't let us. And the answer to that is, I think there's always some compromise between usability and security, and finding that compromise and communicating that to the business is the key step that needs to happen. And there needs to be someone that's the arbiter of that conversation. And so we want to gather a list of ideas and things, and perhaps opportunities to provide alternate anti-automation security controls. Having anything that you deem in your online service that should only be done by a human, there are lots of ways beyond squiggly lines and numbers to identify that. And there's even a lot of ways that it can be done seamlessly without annoying the user. Like, I know, we've had conversations with Oscar's mom. She hates CAPTCHAs. She doesn't understand why you would want to do that. But we understand why, but it's not her job to care why.
Yeah. She feels like she's being punished, or everybody feels like they're being punished when they sign up for the thing. Like, oh man, I need to put this CAPTCHA in. Sometimes you can't even read it. It's not even human readable. So it's like, okay, let me try it again. Deletes your password. You have to type in your password again. It's very cumbersome to use CAPTCHAs in most cases.
And I know that I sent my mom an iPad for Mother's Day, and she still hasn't installed any apps because she doesn't want to put her credit card number in. She doesn't trust the Apple Store. She's like, why do I need to install apps? I can just Google everything. I'm like, you're really underusing your iPad. But the idea being, there are all these opportunities I really like the concept of building in both traffic policies and security policies. And there are even a lot of services that will help organizations that have a legacy API or have a legacy web service put up a proxy in front of that service that helps implement some of these traffic policies and security policies. Doing things like rate limiting or time delays or tracking users, even anonymous users, by their session ID and their IP address, and then saying, okay, the expected behavior on this registration form is that we're going to see one submission every 10 seconds. Maybe they've botched typing in their phone number, or they botched typing in some required field, and they have to go back and 10 seconds later put in and try again. But if we see 100 requests come in a second, that's a violation of our policy. And maybe we didn't prompt them for a captcha right away because that annoys the user, and why would we want to punish every user because there's these attackers that are trying to automate our service? Let's wait until we hit a threshold and have a bit of a logic in our policy that after 10 automated requests in a certain time span, then we're going to prompt for a captcha. And I like this concept of not punishing everyone, but instead only detecting anomalies in behavior or getting heuristics and analytics from the application of something abnormal is happening now. Let's adjust the requirements. Let's now require the captcha, or let's now require the credit card verification, because we're seeing abuse from this IP space, or we're seeing abuse from this session ID, and I think that's how we can strike the balance between usability and security.
Yeah, like another example would be you're seeing a bunch of post requests going to your server without any GET request, or the IP address that is requesting these things isn't requesting any of the JavaScript or any of the images on the page as well. So it's just the post request, because that's the part that's been automated. So that kind of thing can also be identified and added to heuristics.
Right. And I think a lot of organizations can know that normal behavior is that a user signs up and then they go read the documentation for whatever service it is for 10 minutes before they actually go and register a new server in their environment. Not go register an account and then 3 seconds later they have 10 new servers registered. That's very abnormal behavior. So depending on the service, there are things like I do feel like there is value in adding captchas and phone verification and credit card verification. You just have to gauge what that usability and security trade-off is and find those opportunities. Maybe the service, maybe your online service could take advantage of something like a federated identity manager, like allowing your users to log in through Facebook or allowing users to log in through Twitter. Some advantages to that, of course there's pros and cons, but like for example, if you're a bank, no one's going to want to log into their bank with Facebook, but a startup may want to allow Facebook users to just identify themselves with their Facebook account instead of creating a new account.
Yeah, because Facebook actually does a lot of this stuff in the background. They look for fake accounts and they try to keep all of that down to a minimum. So.
Right. If you're looking for like that next cutting edge technique for anti-automation, look to what some of those organizations have done, because they are huge targets for abuse. Facebook actually has something called the Facebook immune system. And they have a lot that goes into analyzing what normal behavior is. Like they actually have heuristics on, does this account that was just created have friends? What's the rate that they're adding friends? Does this look like normal behavior? And then they can gauge whether or not they want to ban that account for abuse. And I think on some scale, some organizations may want to look into building a sensor into their application to do something just like that. There's an OWASP project called the OWASP App Sensor that's actually designed to be something like that, where you integrate that into your code rather than having a WAF or a proxy or something that's trying to detect incoming abuse or detecting abuse at abuse time rather than deterring it before it happens. There's the ability to build in and have really good analytics on the logs, and maybe you really want to focus in on the credit card payment step, and you want to say, whenever we see someone hitting this and testing it with hundreds and thousands of credit cards a day, we know that that's probably someone that's active in the Carter market that has some stolen numbers that they want to test and see if they're valid, and we want to prevent that type of activity from occurring because that's illegitimate use of that functionality.
Yeah, and so I think that there's no actual silver bullet on how to do this kind of this protection, right? And you kind of have to gauge what you're providing with your service, what the benefit to an attacker would be. If you're providing something that's highly beneficial then
they're
coming for you, and you need to add maybe more security controls in that scenario. If the thing that you're providing doesn't have many applications for exploitation, then maybe you can lower the requirements and lower
Yeah. And so maybe make that a goal for the next penetration test or the next assessment, to focus on that most critical functionality and see how it can be automated, and then plan to remediate that or mitigate that with some of the security controls and some of these more advanced techniques. That was really what we hoped that everyone took away. So thank you again for attending. And if there's any questions, please step up to the microphone here in the aisle, and so that everyone can hear you as this is being recorded.
Yeah, we've also actually released the code to some of this.
If you go to our GitHub page, Bishop Fox on GitHub, the code for our inbound mail processing proof of concept is available as of this morning. So please check that out and give us feedback and let us know if you'd like to contribute. Thank you. Yes.
Yeah, I'm curious as to what IP addresses you were using when you were registering all these. I saw you had mentioned IP blacklisting as a potential defense mechanism, and I figure if somebody were going to use this for deeply malicious purpose, they would be using Tor or a VPN or a proxy or something.
We started out with Tor and VPN, and then we would SSH into a free trial account and then launch attacks from one of the cloud providers themselves. So it was always coming, it was basically just, it looked like cloud providers sending commands to other cloud providers.
So in other words, these services, like you would use Tor, and they didn't consider Tor suspicious, or?
No.
Okay.
So yeah, for the actual account registration and stuff like that, we used cloud services. So we'd sign up for one cloud service, and then SSH through that cloud service, and have that one be the one that deployed all the code. Yeah, and then we'd kind of just hop all over the place.
Right,
So
and at that point it's coming from Amazon or Google or Microsoft or one of these legitimate organizations. And that actually is a whole other interesting concept of whenever you have a denial of service attack or some type of attack coming from Google, like no one's blocking all of Google's IP space, or no one's blocking all of Amazon's Google IP space, because there's legitimate business happening there.
Okay, thank you.
I know that in online games and other use cases, there's pretty commonly an input automation. So instead of just having the post request, it would actually open up a web browser, find the confirmation link in the email, click that, the web browser loads it. Would the mitigation mechanisms you have recommended be able to handle this alternate use case?
I think not only relying on that confirmation link is the key step here. Having some other requirements other than going to that email and clicking that confirmation link, some other action that only a human can perform is the best solution. Thanks.
The big question is, did you win?
Of course.
Okay, good. Just wanted to make sure. A lot of trouble.
This situation very resembles the scraping of web content, which is, there are many ways to cope with that web application firewalls usually have.
Right, yeah, and we actually looked a lot to the SEO community and a lot to the web scraping community, and that's a topic that we've both been interested in for a very long time. And they actually have a lot of techniques that I think the computer criminal and malicious attacker community could learn a lot from, because they've been doing web scraping for profit for a very long time. And yeah, I think that that's a lot of organizations are trying to protect their intellectual property from being scraped. And so these anti-automation techniques can be applied for defensive techniques against, maybe that's the threat that an organization wants to protect against. Like Google, for example, they don't want other SEO agents or other search engines scraping their results because they consider that their intellectual property. So they actually have a threshold of how long they will keep an IP address blacklisted in memory, and it's, last I checked, 14 minutes after you hit the threshold of abuse. And they say they've detected you as a bot and you're now blacklisted for a period of time, which costs them resources to blacklist you, but it's more than the resources you were causing on spiking their traffic by scraping their results. And so that's what they've come to some trade-off of what they're willing to do to defend against scrapers as a threat.
How many users did you register?
I'm sorry?
How many users did you register? How many accounts were you able to register?
So we our goal was to create 1,000 accounts just to across multiple different services, and we were able to do that.
Like 100,000 and rest thousands.
No,
Just 1,000.
We just did 1,000 as a proof of concept, yeah.
But it's really just scale of economy of how much more time you want to spend finding more services.
Yeah, I think this is probably the last question we have.
Awesome. Did you guys happen to look into SMS verification, and do you believe that SMS verification is a pretty good block in the road, or is it just as easy to bypass as everything else?
We actually did a little bit of looking into that. It wasn't our main focus, but we'll actually be updating a spreadsheet that we have with techniques of how to bypass phone and SMS verification. We did things like leveraging Google Voice and scraping things out of legitimate Google Voice accounts. There's an app called Phone Burner that lets you generate temporary VoIP accounts and basically get more than one phone number per user, because that still goes back to the concept of, does the user only have one phone number? And there are a lot of services online that will give you temporary free SMS. I think there's actually one called Free SMS online.com that if you go and it basically it gives each day new VoIP numbers in different countries, and then it prints back out to everyone in the world to see what was received at that number. And if you go and look at that, a lot of it's like Google verification SMS or Microsoft Azure Cloud SMS verification. And so we actually leveraged that as a proof of concept to see if we could bypass some services that were relying on SMS. But we decided to shift focus to just the services that were using email because they were the easiest targets.
Thanks.
Mm-hmm.
Thanks. Yeah. For any additional questions, please feel free to come up and ask.
If you want to come up and get our business card or our contact information, feel free. Thank you.